Worksheet number 5. So here I am presenting the solution of the worksheet number 5, the chapter number 5, electrical circuits and the Ohm's law. So here the part 1, multiple type questions, MCQ. The question number 1: if a charge of 3.2 into 10 to the power minus 6 coulomb passes a given point in a circuit in a time of 100 nanosecond, so determine the value of the current. So here in this question you have to find the value of the current. So here you have to find the value of the current. This current you have to find. Now this the value of the Q is given and the value of the time is given. So the relation between the current, time and the charge is the I equal to Q over T. So this is the formula, or this is the relation between the charge, current and the time. And according to this formula we can write the value of the parameter. So this is I equal to the value of the Q is, this is 3.2 into 10 to the power minus 6 coulomb, and it is divided by the time. So here it is a nanosecond, so this nanosecond you have to change, and this is 1000 multiplied by nano means 10 to the power minus 9, and this is second. So after solving the answer will come 3.2 ampere. So the option number A is the correct option. Now the question number 2: a current in 8 kilo ohm resistor connected 120 volt DC supply is equal to. So here in this question you have to find the value of the current in 8 kilo ohm resistor. So this is the value of the R, and connected to DC supply, so this is the value of the voltage, and equal to what? So there is a Ohm's law, and the formula for the Ohm's law is V equal to IR. This is the Ohm's law, and if I take I from here, so this I is equal to V over R. So this formula we have to use, and according to this formula the voltage here in volts it is 120 volt, and 120 volt, and divided by this kilo you have to change. So this is 8, and the meaning of the kilo means this is 10 to the power 3 ohm. So this kilo is changed. Now let us calculate. Now after the calculation the answer comes, this is 0.015 ampere. So this answer is coming, and if we look at the option, so this option is not matching, and in ampere here it is coming 15 ampere, and this is 960 ampere. So this is not same, and here the one is 1.5 milliampere. So two options are given in milliampere, here milliampere, here milliampere. So if I change this in milliampere, so this will be 15 after changing to milliampere, so this will be 15 milliampere. So according to this 15 milliampere, the option number B is the correct option. Now let's move to the question number 3. Now the question says, when a third resistor is connected in series with the two resistors, the total resistance will be what? The option A is remains the same, increase, decrease, or increases by 1/3. So the question says there is a one circuit and in the circuit already there are two resistors. So this is you say this is the resistor R1 and this is the resistor, this is R2, and say this is 10 ohm and say this is 5 ohm. So there are two resistors already connected. So the total resistance of this circuit is, this is the formula for this one, how to find the total resistance. So the formula is the R1 plus this is R2 and this is 10 ohm and this is 5 ohm and this is equal to 15 ohm. So now the total resistance of this circuit is coming 15 ohm. Now the question is saying, if I am adding one more here, if I am adding one more, okay, you say if you add, let us suppose say minimum value, say minimum to minimum, let's say it is 0.1 ohm, very small value. So they are saying if any resistor is added, say this one, so now the total resistance will increase or will decrease, or what will happen? So now if there are three resistors, so the sum of the three resistor will be like this. So this is 10 and this is 5 and this is very small, which we are adding the last one. So this is equal to 15.1 ohm. So now if we are adding the third one, maybe small value or maybe big value. So if you compare this and if you compare this, so this is bigger. So this value is always bigger value. So here remains same, increases. So the option number B is the correct option. Now the question number 4 says two resistors R1 20 ohm and R2 40 ohm are connected in series. This circuit is connected with 100 volt battery. A current of 0.2 ampere is passing through R1. Then the current passing through R2 is how much? So let's make the circuit. What the question is saying, I am making the circuit according to that. So the circuit is, there are two resistors and this is R1 and this is R2 and this is connected across the battery, and the battery is 100 volt, and this is R1 and this is R2. So this is 20 ohm here and the R2 is 40 ohm, and they are saying in this circuit the current is passing, that is 0.2 ampere. So this information is given here. Now they say the current of 0.2 ampere is passing from here. This current is passing from here, passing from R1. So how much current is passing from R2? So there is a one rule. This is the rule of the series circuit. The rule of the series circuit, and the rule is the current is same in the circuit. Whatever the current is passing, so the same current will pass through all the components connected in that series circuit. So here if they say from the R1 the current is passing 0.2 ampere, so from the R2 the same current will pass. This is the rule. Now the question number 5, for resistors in series, which one of the following statement is false, which is wrong? The option number A is the voltage across each resistor has different value. So let us take for example, if I say there are two resistors and they are in series. So this is R1 and this is R2, and this is connected across the battery, and the battery is V, and here the current is passing, say this is I, and there is some voltage across the R1, so I am saying the voltage is VR1, and here the voltage is, that is this is VR2. so I am saying the voltage across the R1 is VR1, say, and the voltage across R2, say the voltage is VR2, like that. Now come to the option number A. The voltage across each resistor has different values. So yes, this is correct. So there is a rule of this kind of circuit, the rule of the series circuit, that the voltage across R1 is equal to the voltage across R2 is not equal to, voltage across R1 is not equal to R2. So this is which is false. So this is correct. Yes, this is correct. The current through each resistor, option number B, the current through each resistor has different values. No, this current is same. So the current in this series circuit is same. The current through each resistor has different values. So this is wrong. Yes, so this is wrong. So in the question you have to find which is false, which is wrong. So this is the correct option. So now the part 2, answer the following. So this you have to define: what is insulator, what is conductor, what is electric current, what is potential difference, what is resistance. So this is a theoretical questions and you have to define. And now give the statement of the Ohm's law. So this is also given in your chapter, in your PPT, the statement of the Ohm's law. If in the examination it comes, give the statement of the Ohm's law, so you have to write in the words, don't write the formula, you have to write in the words only. So now the part 2, define the ohmic material and non-ohmic material. So you have to define ohmic material and the non-ohmic material with the help of the diagram. So for the ohmic material, the graph with the help of the diagram. So with the ohmic, this is for the ohmic, this graph is for the ohmic, the first one, this is for the ohmic. So if I make the graph between the V and the I, so the graph is a straight line. So this kind of curve is coming. So this is for the ohmic materials, and for non-ohmic material the graph is like this. So if I plot the graph between the V and the I, so the graph is like this. Okay, so it is not straight. So here the graph is coming straight always for the Ohm's law, for the ohmic, always straight. But here if you see, the graph is moving like this, so not straight. So this is for the non-ohmic materials. So now in the question number 3, what is increase in current when 15 volt is applied to an electric device of resistance 2000 ohm when it is replaced by 5000 ohm? So you have to find the current increment. So in these two cases there are two values, okay, two values and the same source. So this source is same in both the cases. So here, so this is for the, you say this is R1 and this is, you say this is R2. So the two resistors are there and one by one they are using, and if I make some resistors circuit, so it is like this. So here there is one resistor, so this is R1 and this is connected across the 15 volt. So here this is 15 volt and the value is 2000 ohm. So how much current is passing? So find the current here. Say you say the current is, say, I1. Now they say if this resistor, okay, this resistor is replaced by another higher value of the resistor, and that is the 5000 ohm. So this is for another one. So this is, say, this is R2, but the same battery is there. So this is same battery, and this is 5000 ohm, and here you find the value of the current. Say this is I2. Okay, so how much current will be increased, or like that. So here for the case, okay, so like two cases are there. So for the case 1, if I find the current, this is I1 and this is V over R1, and this V is 15 and this is divided by 2000, and this is equal to, let's calculate. Now in this question, the two circuits I have drawn and the two cases are there. So in the case 1, when the resistance is 2000 ohm, so the current is coming, that is I1, the current is coming 7.5 into 10 to the power minus 3 ampere. Now in the case 2, this 2000 ohm resistance is replaced by 5000 ohm, the higher value. So we made the case 2 and found the current I2 in the other circuit, that is V over R2. The V is same, that is same power supply, and here the current is coming 3 into 10 to the power minus 3 ampere. Now after getting the two answers, so here the current is going, the current is not increasing, the current is basically decreasing. So it is better to say in the question what is the increase. Basically it is the if I say what is the change in the current, it is the better way to ask the question, what is the change in the current when the 2000 resistance is replaced by 5000 ohm resistance. So here the change in the current, use this formula del I equal to I2 minus I1, and this I2 is, I have taken 3 into 10 to the power minus 3 from here. This is I2 from here, and this is I1, and the answer is coming this one. But here it will come with the minus sign, so don't take with the minus sign, because here we are finding the difference. So when we find the difference, so what we do, we take the mod here. Mod means, okay, mod means this is always plus, it will never be with the minus sign, because we are finding the change only. Now the part third, show a neat and detailed solution starting with the formula and the equation. So the question number 1 and the part A, if there is a current of 20 ampere in a circuit for 10 minutes, what is the quantity of electric charge? What is the quantity of electric charge flows through the circuit? So now the question says there is one circuit like this. There is a one circuit like this, and this circuit, and in this circuit. Okay, so in this circuit the current is passing 20 ampere, and it is flowing for the time 10 minutes. So how much charge will flow? So the formula for the charge is, that is, this is I equal to Q over T. This is one formula which is showing the relation between the current, charge and the time. So by using this formula we can find this, the Q equal to, this is I into T, and by using this formula, so the value of the I is 20 ampere. So this is okay, and here the time is given in minutes. So this minute you have to change. So how you can change this minute in 1 minute? There are 60 seconds. 1 minute 60 seconds. So this is 10 multiplied by 60. So this is equal to 600 seconds, and here it is 600. So this is 600 seconds. Now it is equal to 6 to 12, and this is 12,000 coulomb. So this is the answer. And in the part 2, the number of electrons present in the charge. So there is a one formula between the charge and the number of electrons. So this formula is Q equal to Ne. So in this formula, this N stands for, this is a charge in coulomb, and this N stands for the number of charges. So this stands for the number of charges, number of electrons, and number of protons, whatever. And this E stands for the charge of the electron. So this is constant here. The charge of the electron is constant. So here find the number of electrons. So here you have to find N. So this N equal to this Q over E. And here we are getting, so this is 12,000. So here we are getting the 12,000 coulomb. So this is 12,000 coulomb, and the value of the E is, this is 1.6 into 10 to the power minus 19, and after the calculation the number of electrons will be, so after the calculation this number is coming 7.5 multiplied by 10 to the power 20 10 to the power 22 number of electrons. So this number of electrons are coming. So now the question number 5, in which manner resistors are connected in the given circuit diagram. So when this circuit diagram is given, so you have to define in which manner the circuits are connected. Manner means the circuits are in series or they are in parallel. So this circuit is a series circuit. So this circuit is a series circuit. Answer. Now the part 1, this part 1, find the total resistance of the circuit. So here this is, you say the one resistor here, one resistor here, one resistor and one resistor. So the total number of resistors connected here in this circuit are 4. So so what you can do, you can give some names to these resistors. So let's say this is R1, this is R1, this is R2, and say this is R3, and say this is R4. So find the total resistance of the circuit. So the formula for the total resistance of the circuit is, so the formula is R1 plus this is R2 plus R3 and plus this is R4. So here this is the R1 is 2.5 kilo ohm. Okay, so you can first you take in kilo ohm, and after that we can change. So this is 2.5 kilo ohm, and this is 1.5 kilo ohm, and this is 3 kilo ohm, and this is 1 kilo ohm. So now after this is 4 kilo ohm, 7 kilo ohm and 8 kilo ohm. So the total value of the resistance is coming, this is 8 kilo ohm, and we can change the kilo, and this is 8 multiplied by 10 to the power 3, and this is ohm. Now go to the part 2. Now find the total current in the circuit passing through. So for this you have to use the Ohm's law. If you have to find the current, so Ohm's law you have to use, and the Ohm's law is V equal to IR, and from this formula you can take I one side. So this is I equal to V over R, and the voltage, so let's see what is the source voltage here. The source voltage is 200 volt. So this is the 200 volt source voltage. So this is 200 volt, and the resistance is 8000, and let's calculate the value of the current. So this is 2000 divided by 8000, and the answer is coming the answer is coming 0.025 ampere. Now here the part third, find the voltage across 3 kilo ohm resistor. So the question says, what is the voltage coming here? So the voltage across this voltage, so the voltage coming here, this voltage means the voltage across, I say the voltage across R3. So we can write this is VR3. So here, how to solve this kind of question if they are asking the voltage across the particular question. Now what we have to do, we have to use the Ohm's law. For this, the Ohm's law in this section. So in this section, the voltage is coming VR3, and here this is I, and the R is, this is R3. So because I am using the Ohm's law here in this section, so I will take the value of this R, not the total circuit. So this formula I am using here. So the formula, find the voltage across 3 kilo ohm resistor. So this is the voltage across R3, or the voltage, we can write like this also, the voltage across 3 kilo ohm, and this is equal to I and multiply by R3. So already we have calculated in the part 2 how much current is passing here. This is the amount of the current. So this is the amount of the current, 0.025 ampere current is passing in the circuit, and this current is coming from here, coming from the source. So in this circuit, the current is passing, that is 0.025 ampere. This current is coming from this source, and this current is passing from here, the same current is passing from here, and the same current is passing from here. So this is the rule of the series circuit. How much current is coming from the source, so the same current will come here, same current will come here, same current will come here, and the same current will come here. So the current is uniform, the current is constant in the series circuit. So I will take the value from there, and this is 0.025, and the value of the R3 is 3 kilo ohm. So I will take 3000 ohm. So in ohm I have to take, not in kilo ohm. And after the calculation, so this is 0.025 multiplied by 3000, and the voltage is coming, that is 75 volt. So this is this voltage is coming 75 volt across the 3 kilo ohm resistor. Now the question number 8. In the question number 8, this question is based upon the Ohm's law, but in the graphical form. So the two resistors are RA and RB are connected in series to a voltage source of 110 volt. So the question says, so according to the question is saying the two resistors RA and RB, they are connected in series. So I will make one circuit according to the question. So this is RA and this is RB, and this is connected across one source, and the source voltage is given, this is 110 volts. Say this is RA and this is RB, like that. Now the part A says find the value of the RA and the RB from the given BI graph. So from the graph you have to find the value of the RA and the RB. So now there is a rule, if you have the VI graph. So this I am telling you the rule about this. If you have the VI graph like this, and you have one line like this, and it is always like this, and you are finding the value of the R, you are finding the value of the R from this graph. So what you have to do, this R is equal to the slope. So you have to find the slope of this graph. Okay, so let's take here, this is, say this is A, and here say this is B, and you come down, so say, okay, so this is I, you say this is I1, and here you come down, so say this is I2, and here you come, so you say this is V1, and here you come down, so you say this is V2. So the slope will be like this, and it is, the y will be up, so this is V2 minus V1, and this is I2 minus I1. So this rule or this formula we have to use to find the value of the RA and the RB. So let's take this RA. So what you have to do here, you have to choose any 2 points anywhere. So let's say this point is here, this point I am choosing the A point, and this point I am choosing the B point. So the calculation, so here I am calculating for RA. So RA I am writing the slope, so this is V2 minus V1, and this this is I. So this is I2, so this is I2 minus I1. So here, so when you will come down, here, so this is the value of the I1, and from here, whenever you are coming down from here, so this is the value of the I2, and here this is the value of the V1, and when you will come from here, so this is the value of the V2 for this RA. So now the value of the V2, so the value of the V2 is 12 volt minus 4 volt, and the I2 is 6 ampere minus 2 ampere. So this is equal to 8 by 4, and this is equal to 2 ohm. So the value of the RA is 2 ohm. So in the same way, we can find the value of the RB by using the slope. So this is V2 and this is V1. This V1 you cannot use, they have their own coordinates. So this is I2 and this is I1. So now let's take this one, so for this graph, okay, and you forget about the points that you have taken for this, forget about this one. Okay, now what you have to do, you have to choose new points for this RB. So if I take, okay, so if I take this A point and this B point, so it is coming from here. So this is the value of the I1, and this is the value of the I2, and this is the value of the V1, and this is the value of the V2, okay, for the RB. So now you can put in the formula V2, this is 11, so here it is coming, this is 10, 12, so this is 11 here. So this is the V2 is 11 minus 5, and it is divided by, so this is 11 also here. So this is 11 minus 5, and this is equal to 11 minus 5, it is 6, and this is 6, and this is 1 ohm. So here we got the value of the RA and the RB, that is the 2 ohm and it is 1 ohm. So this way we can find the value. And now determine the equivalent total resistance of the circuit. So now here this is the circuit, so the values came here, So this is coming 2 ohm and it is coming 1 ohm. So they say in the part B, what is the total value of the, what is the total equivalent value, what is the total equivalent value of the circuit. So you can use the formula. This is RT and this RT is equal to RA plus this is RB. So this is, you can put the value. So this is 2, this is 1, so the total value is coming 3. Now determine the current in each resistor. So determine the current in each resistor. So your circuit is like this. This is RA, this is RB, and here this is the value of the source voltage. It is how much? 110. So this is 110, this is 110 volts. So this is the RA and this is RB. So this is 2 ohm and this is 1 ohm. So here this is the value of the current which is coming from the source. Now the circuit says determine the current in each circuit. So what is the total current of the circuit? Same current is passing from here. This is the rule. Okay, so determine the current through each resistor. So it means you have to find the total current here. Total means how much current is passing in this circuit. So for this you have to use the Ohm's law. For this you have to use the Ohm's law, and this is V equal to IR, okay, total, and you can say this is total current. So you have to find the current or the total current which is passing in this circuit, and this is V over RT, and the voltage is 110 and this is 3 ohm, and let us calculate this value. So this is 110 divided by 3 and it is coming 36.6. So this is coming 36.6 ampere. So so the meaning is, because this value is coming, so here this value this value is coming 36.6 ampere. So the question says how much current is passing from 2 ohm, same current. So this is how much? This is 36.6 ampere, and how much current is passing from 1 ohm like this, and this is also same, because this is the rule of the series circuit. Same current passes through the series resistors.